When you hear the word magnet, you probably think of hanging something up on your fridge or maybe an Etch-a-Sketch. The last thing you'll think of is biology. When I hear the word magnet, I immediately think of the bacteria Magnetospirillum magnetotacticum. These bacteria generate small iron magnets inside specialized compartments called magnetosomes. And these magnets are extremely useful for a variety of next-generation medical technologies. Just to name a couple examples, they've been used to make biosensors that can detect cancer in its early stages. They've been used as mRNA agents, and they've been used as drug delivery vehicles. So clearly we care a lot about these particles, and we would love to learn more about how exactly these bacteria make them. However, there are a lot of difficulties that come with studying these magnetosome compartments in which they're made. The primary one being that because they're inside the bacteria, there are also hundreds of thousands of other processes going on at the same time. In other words, it's very difficult to observe just one thing at a time. It's as if there's a Where's Waldo going on in your bacteria. So our solution to this is to replicate the magnetosome outside of the bacteria. Ultimately, we want to mimic this biological system, but mimic it in a simpler way so that it's a lot easier to study. And so to do so, I'm using something called peptide-polymer particles. As the name suggests, there are two components, one being the polymer. This is a type of chemical that's used in plastics and rubber. It's ubiquitously ubiquitous. And the other portion is peptide, which is just another word for a very short protein. And it's at this peptide portion where we can put different proteins which are involved in the compartment which makes the magnet in this bacteria. And just to give you a visualization of what this looks like, this is an image taken with an electron microscope where each of the small circles is this peptide polymer particle. So now that we've shown that we can successfully make them, we're currently working on incorporating those magnetosome proteins that we care about studying more into this particle. So ultimately, by creating a biomaterial that mimics a biological system, we're aiming to bridge the gap between a complex organism to a simpler chemical system and ultimately to these medical technologies that arise from these magnetic nanoparticles. Thank you.